So in this lesson, we talk all about diffuse ray depth. We are done with the sampling settings and we'll discuss the rest of the parameters there in the rendering section of the course. As we know, sample settings control the quality of our render and we use it to remove noise from our different ray types. Ray depth settings control how far a ray can pass in our scene, how many times a ray can bounce in the scene. Now, as you can see in the ray depth section, we have diffuse, specular, transmission, volume, and transparency controls. Diffuse ray depth controls the number of GI diffuse bounces or indirect diffuse bounces. As we are working with diffuse ray depth, I'm going to override all these materials in the scene with a Lambert shader. So in the material manager, create, Arnold, surface, and Lambert. Lambert basically is a simple material with only base or diffuse component with its weight set 2.7, which gives us a 70% gray color. Let's run the IPR now. To set a shader as your global shader override, in the render settings, go to the diagnostics tab and under feature override, assign your desired material as the shader override, and now this shader is applied. If you remember in a previous lesson, we used the debugging function in the IPR to get a clay render, but you can assign a shader override as well. It's up to you. Also, I have a warm light inside this floor lamp, which I'm going to turn it off for now just to keep the scene as simple as possible. All the lights in the scene have 4 or 5 samples, so we don't get any direct diffuse or specular noise from them. At the moment, we have our diffuse sample set to 2 and our diffuse ray depth set to 0. And this is the render we get based on these settings. Now, let's zero out diffuse ray depth. By doing so, you're basically limiting our direct light rays to have any sort of secondary bounce. So that is why if you take a look at the area where direct light can't reach, for example, under the couch, because they are not exposed to the direct lighting and we limited our light rays to have any GI diffuse bounce by setting the diffuse ray depths to 0, they obviously are going to be black and dark. We can take a snapshot so we can compare the renders later on. As soon as I increase my diffuse ray depth to 1, we introduce GI diffuse bounce to our scene and we are allowing our direct light rays to bounce 1 time. And as you can see from the IPR, those dark areas are now brighter. We can take a snapshot again and quickly compare this render with the previous one. In the first render, we had no GI diffuse bounce and we have these kind of very dark areas. In the second render, we have 1 diffuse ray depth and we are allowing our direct light ray to bounce 1 time. So a light ray hits a surface, it won't be killed off there. It bounces from that surface and illuminates another surface with smaller amount of energy and illumination when it hits it. That is why those previously dark areas are getting brighter. If I increase my diffuse ray depth to 2, we are going to make those dark areas even brighter because we are letting our light rays to bounce more in the scene and travel between surfaces. Let's take another snapshot. And let's increase our diffuse ray depth to 3. And this is the result we are going to get. The scene is brighter, and because we are allowing for more light bounces, the overall result is physically more accurate and more realistic. And if we increase it to 4, the same thing would happen. The scene is going to get a bit brighter and physically more accurate. For most scenes, you don't need anything more than 3 or 4 diffuse ray depth. Anything more than 4 wouldn't have a noticeable effect, so let's leave the diffuse ray depth at around 4. One thing I hope you noticed is the fact that even though we are increasing our diffuse ray depth, the indirect or GI noise is still there. Ray depth has nothing to do with quality and noise. If we want to get rid of the GI diffuse noise, we need to increase our diffuse samples. Just a quick tip here, as you are increasing your diffuse ray depth to get a brighter and more accurate scene, remember the cost of doing that is the GI noise will be more visible and cleaning it up using diffuse samples will be harder and we would need higher diffuse samples which will increase your render time by a lot. So make sure you use as much diffuse ray depth as you need. For most scenes 2 is enough, but for more complex scenes like this one, you can use something like 4. Now to clear the diffuse noise, let's set the diffuse samples to around 8 and see what we get. Now if we take a snapshot and compare it to our previous render when we only had 2 diffuse samples or 4 diffuse samples, you notice the render is much cleaner, but it took almost 6 times longer. So that's about diffuse ray depth. Before wrapping up this lesson, let's increase the settings for a nice final render. Let's just clear the shader override and turn on the floor lamp. We can set the camera samples to around 5, 6. I think something like 7 would be enough for the diffuse samples as we increase our camera samples already. Specular and transmission samples could be around 4. Actually, transmission sample could be anything because we don't have any transmissive shader. And as we have some subsurface scattering effect in the plant and in the lampshade, I'm going to set my SSS samples to around 6. Diffuse ray depth could be 4, and I'm going to set the specular ray depth to around 2, just to get more realistic specular reflections. We talk about specular ray depth in the next lesson, and this should give us a clean render. Any remaining noise can be dealt with using Arnold denoiser, which is really capable and will be covered in the rendering section. Let me show you the final render. I have already rendered it and took a snapshot, and here it is. So I'm also going to take a high resolution render and save it to the render folder in the project files folder. So in this lesson, we covered diffuse ray depth, and in the next one, we discuss specular ray depth. So see you there.